Good morning, guys. Yesterday, you should have watched a video over the rational zero theorem, which helps us list all possible zeros of a certain polynomial. So today, we're going to use that theorem to actually find the real zeros of any polynomial. So step one is, of course, to first find all the possible. So list all possible rational zeros using the theorem from yesterday. Once you have that list, so it's not going to be a short list. It'll be a list of about 20 numbers. You're going to have to test some of those zeros using synthetic division. So basically, we're taking a guess. So we're guessing from that list whichever numbers we think it might be. And then once you find one that works, it'll make your polynomial smaller, and then you can completely factor from there. And once you factor, then finding zeros kind of comes easily. Okay, so example 4, because we're continuing the notes from yesterday, says list all the possible rational zeros and then find the actual zeros. So normally we would try to factor, right? So I would do factor by grouping. Over here it's x squared 2x minus 5. But it ends up not being the same thing for the second half. So I can't factor it the way I normally would. So this is why we're going to use the rational roots theorem or the rational zeros theorem. So remember that the last number, 6, that is P. And the first number, 2, that is Q. So when we're finding our rational roots, we need to find all the factors of these. So starting with P, so 6, what are all the factors of 6? Well, I could do 1 times 6, and I can do 2 times 3. So I'm just going to list them, 1, 2, 3, and 6. Okay, and then for Q, it's just 2. 2 is a prime number, so the only way to multiply and get 2 is 1 times 2. Okay, so now for our possible zeros. So these are going to be all of our possibles. We have to set them up as fractions. But remember, they're positive or negative. They can be either one. So I could have 1 over 1, 2 over 1, 3 over 1, 6 over 1. So I'm going to list those. Plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, so we're done with that 1. But now we need to work with the 2. So I could have 1 over 2. That's 1/2. Plus or minus 1/2. I could have 2 over 2, but that simplifies to 1, which is already on the list. I could have 3 over 2, so plus or minus 3 over 2. And then I could have 6 over 2. 6 over 2 simplifies to 3, which is already on the list. So this is our entire list right there. Those are all of the possible zeros. So yes, it's a long list, like I said, but it's better than guessing from infinite numbers. Instead, now we're guessing from 1, 2, 3, 4, 5, 6. We're guessing from a list of 12 numbers. Because remember, positive 1, negative 1, positive 2, negative 2. So we narrowed it down to 12 possible zeros. Let's find the actual zeros, though. So the way we're going to do that is the factor theorem that we did on Friday. So if it is a true factor, I should be able to divide by that number and get a remainder of 0. If I get a remainder that's not 0, then it's not a real factor. So I'm just going to start from the beginning of the list, and let's try 1. Okay, so 1 in the box, and I'm dividing our original polynomial here. So I'm going to get the coefficients, 2, -5, -1, 6. Okay, and then we're going to do our synthetic division. So automatically, I bring that 2 down. Okay, then we're going to do some multiplying. 1 times 2 is 2. Then we add those numbers. -5 plus 2 is -3. And continue that until we run out of numbers. 1 times -3 is -3. Add those numbers, and that's -4. 1 times -4 is -4. And if I add those numbers, I get 2. Okay, so that number, 2, that's our remainder. So the thing is, that is not equal to 0. So that means that 1 is not a factor. This is not a real factor. If it was, I would have had a remainder of 0. Okay, so let's try the next number. So now I'm going to try, I'm still on the 1. I tried the positive version, so now let's try -1. Okay, so -1. Same coefficients because I'm still dividing that same polynomial. 2, -5, -1, 6. Okay, we're going to bring that 2 down. -1 times 2 is -2. And if I add these numbers, I get -7. -1 times -7 is +7. And if I add these numbers, I get +6. Then -1 times 6 is -6. And if I add these numbers, I get 0. Which is good, which is exactly what you wanted. So if it has a remainder of 0, that means it divided it evenly. So now that I know that that original polynomial, this f of x right here, so f of x, I could write it as, remember this, I have to turn it into a 0. Or like right now it is a 0, I have to turn it into a factor. So actually I'm going to write that next to it here. That would be x plus 1. I know that kind of seems, it's opposite. It actually is opposite. So I know that one of my factors is x plus 1 times everything that I had left over here. So since I started with the third power, this is going to be to the second power. So 2x to the second power minus 7x plus 6. Okay, so it's not completely factored, but at least I got this one out of the way. And now this, what's left over, that's quadratic, which should be hopefully easier to factor from here on out. So let's try. So I know to factor this, I need to multiply that first and last number. So 2 times 6 is 12. But when I add up whatever factors I get, it needs to equal what's in the middle. So it needs to equal -7. Okay, so I could do 1 times 12, 2 times 6, 3 times 4. But I know that all of these are positive, so when I add them, I'm going to get a positive number. So what we could do is change everything to negatives. So -3 times -4, negative times a negative gives me this positive, but when I add them, that's going to give me my -7 that I need. So those are the two numbers I'm going to use. So now, this right here, I know there's an x in each one, and we said the two numbers are -3 and -4. But the way we check our answer is that when I try to multiply these back, I should get to the original. So this leading coefficient, we're going to divide by that number. So let's divide by 2, divide by 2. 3 over 2 is not going to simplify, so we're just going to get this bottom and move it up. 4 over 2 does simplify. Okay, so now this is going to be our final answer, I think. F of x is equal to, so I still have that x plus 1. I'm still keeping this one. But here, this 2 is moving up, so this is going to turn into 2x minus 3. And then for this factor, I know that 4 divided by 2 is 2, so that'll just be x minus 2. Okay, so that is it, completely factored, as much as we can. But the question was asking us for the actual zeros, so that means that we need to solve each one of these. So what I'm going to do is set each one equal to 0. X plus 1 equals 0. So that means that x would equal -1. So that is one answer. 2x minus 3 equals 0. Add 3 and then divide by 2. So x equals positive 3/2. And then that third one, make it equal 0. I would add 2 to both sides. So x equals positive 2. So these are the 3 zeros. Just make sure that you write them as a set, and we're going to write them from least to greatest. The good thing is that it already looks like it's least to greatest. So x would equal, when we do sets, we do that curly bracket, -1, 3/2, and then 2. Close the curly bracket. Okay, so an interesting thing to look at is now that we know that those are the actual zeros of that polynomial, like if I were to graph it, this is where it's going to cross the x-axis. If you go back and you look at your possible zeros, they're all on the list. So -1 is here, 3/2 is right here, and then 2 is here. So they were all on the list. Okay, so let's do one more just for the practice. We have 3x cubed minus 8x squared minus 33x minus 10. Again, if you try to do the factor by grouping, it ends up not working out. Over here, there's nothing that simplifies, so they're different. Can't do factor by grouping. So instead, what we're going to do is look for our possible zeros. The last number, that's p. So factors of 10 would be 1 times 10 or 2 times 5. So I'm going to write them in order. Then the first number is q. Okay, so 3 is prime. The only way to get 3 is 1 times 3. So for our possibles, so possible zeros, what you're going to do is p divided by q. So again, all over 1, so 1 over 1, 2 over 1, 5 over 1, 10 over 1, they all stay the same. So plus or minus 1, plus or minus 2, plus or minus 5, plus or minus 10. But now we need to put them all over 3. So I would have 1/3, 2/3, 5/3, and 10/3. None of these simplify to something that's already on the list, so we're just going to write them all down. So plus or minus 1/3, plus or minus 2/3. I'm going to cheat a little bit. I'm running out of space. Let me move this over. Plus or minus 5/3. Oops, let's do it a little bit more. And plus or minus 10/3. So those are all the possibilities that it could be. Okay, so instead of having a guess from the infinite numbers that we have 1, 2, 3, 4, 5, 6, 7, 8. So 16 options. If you want to take a guess and guess from the middle, you can. And maybe you'll get lucky and hit one that's already the answer, but I'm going to do the same thing as I did before, and let's just start from the beginning. So I'm going to start with -1. Okay, -1. And we're going to divide this polynomial here. So 3, -8, -33, -10. Okay, and then let's see what happens. We'll bring down the 3, multiply here, so that's -3, add, that gives me -11. Negative times a negative makes this +11, so that would be -22. Negative times a negative makes this +22. which when I add that is 12. So that last number, it didn't equal 0. So that means that -1 is not one of the zeros. Okay, let's try +1 now. Let's try +1. So +1, 3, -8, -33, -10. Bring down to 3. 1 times 3 is 3. And when I add those up, that's -5. So I'll bring my -5 here. This is -38. -38, adding is -48. So again, that's not 0. So that's not a factor. All right, so now so I know that 1 and -1 didn't work. Well, now let's try the 2. So let's try -2. -2. We're still dividing that same polynomial because I want to see if it's a factor of this one. So 3, -8, -33, -10. Let's bring down the 3. -2 times 3 is -6. And when I add those up, that's -14. Okay, negative times a negative is going to make this +28. And when I add those, that's -5. Okay, and then negative times a negative is going to make this +10. And when I add those, I get 0. So that works out. So finally, we found one that is a factor. So -2 is a 0, meaning that x minus 2 is a factor. So the polynomial from up here, this one here, I could rewrite it as f of x equals, okay, so this linear factor, x minus 2, times the answer that we got here. So 3x squared minus 14x minus 5. Okay, but same as we did before, I want to factor this completely. So now just this second part, this quadratic, let's factor that. So we're going to get the first and the last number. So that would give me -15. If I get factors of -15, so 1, -15, 3, -5, -1, 15, and -3, +5. So it kind of looks like I did the same thing twice, but all I did was I changed where I put the negative sign. I need it to equal -14 when I'm adding. So it looks like that's already going to be the first one. Okay, so this can be changed to x plus 1, x minus 15. But just like we did before, since I have that leading coefficient of 3, we're going to divide by 3. So now that polynomial, I still have the x minus 2. All I'm doing is bringing that factor down. But now here, x plus 1 over 3 doesn't simplify, so get that 3 and bring it up. So 3x plus 1. And then here, x minus 15 over 3. Well, I know that 15 over 3 is 5, so I'm just going to write x minus 5. Okay, that's the polynomial completely factored into its linear factors. But now we want to solve them, so let's set them all equal to 0. X minus 2 equals 0 means that x equals +2. Oh, I'm sorry, this was supposed to be a plus. I knew something was off. Okay, so this was supposed to be a plus, meaning that it would equal -2. There we go. Then here, 3x plus 1 equals 0 means that x would equal -1/3. Okay, and then the third one, x minus 5 equals 0. Add 5 to both sides, so x would equal +5. Okay, so those are the three solutions, but we're going to write them in order from least to greatest. It actually already looks like they are least to greatest. So as a set, -2, -1/3, and +5. Those would be the three zeros of that polynomial. This is where it crosses the x-axis. And just to double check, all of those should have been on your list of possibles. So -2 was right here. -1/3 is here. And +5 is here. So they were all on the list of possibles. Okay, and that's how you find rational zeros of polynomials that are not easily factored.